Good day. So here we have yet another example of integration by parts. So as you should probably know by this point, the first step of integration by parts will be to figure out what our u and what our dv, what both of them need to be from the original function. Once we determine that, and if we pick the right things per se, what's going to happen is that it's going to be a piece of cake to integrate, since we just plug things into the formula and then boom, it's done. But the problem is that we won't always just be able to eyeball the function and determine what u is and what dv is really quickly and really cleanly. So because sometimes what's going to happen is that we're going to pick the u that's going to make things worse. So in this case, for example, it might be tempting to think, okay, well, maybe the u is just going to be x and the dv is going to be ln x dx. If you give that a try, you're going to quickly see that we're going to get a worse integral than what we had originally. Okay? So, but of course, like when you're practicing, you can give it a try and see what happens. But in this case, what we're going to need to do is set the u as ln of x. And our dv is actually going to be, well, that barely looks like a d. Our dv is actually going to be x dx. And of course, we're usually going to pick a dv that's going to be easy to integrate. And, well, nothing is easier to integrate than just x, right? Because we're just going to get x squared over 2. So, without further ado, let's just work out our du. And how do we do that? Well, we're just going to take the derivative of ln of x, which is 1 over x, and we write the differential dx, because we differentiated, so we took the derivative with respect to x. Over here, now we need to figure out what v is. And the integral of x is just x squared over 2. And of course the differential is gone because we integrated both sides. Great. Now what do? We can just plug everything into the formula right here. So u times v, our u is ln of x, and our v is just x squared over 2. Now we're subtracting the integral. Now what is v? V is x squared over 2 of du. And du is just 1 over x dx. So look at how nicely this is going to work out. X squared over x, they just cancel out, so I get just essentially x times 1 over 2, so x over 2 dx inside of the integral here. Over there, I'm just going to simplify this. I guess I'll just write, leave the 2 on the bottom. So I have ln of x times x squared over 2. If you want, you can put the x squared in front, doesn't matter. And now over here, I'll take out this 2 outside as a half, actually, because essentially the x over 2 is just the same thing as half times x, right? And I can always take out the constant from inside the integral. So I have the integral of x, and the integral of x is just going to be x squared over 2. And the negative half stays outside here, of course, multiplying the x squared the x squared over 2. And we're adding a constant at the end, of course, like always. So I'm just going to rewrite this as x squared ln x over 2. And now we're basically done. I'm just going to simplify this a bit. So we have x squared ln x over 2 minus x squared over 4. Just multiply the 2 times 2 and adding the constant at the end. And that's it.